Good afternoon, guys. My name is Ravi Venkat. I'm a solution architect at Pure Storage. It's a all-flash storage array company. I've been a V expert for 2013, waiting for my 2014 nomination results. I'm also a VCAP DCA, worked in the industry for a long time. I worked at VMware for 3+ years, then Cisco UCS Group, so I have a combination of network storage, server, and virtualization background. So today I'm going to be talking about flash accelerated data centers. So flash in data center was a topic I picked up. There are multiple kinds of flash in the data center. Sometimes you may not even be aware of. So you don't have to have a flash array to have a flash in a data center. So I'm going to go through multiple of these technologies and why it matters in the current world. So this is not a architecture slide, but I kind of went and did a research on what is happening in the industry over the last 15, 20 years. When VMware was early days, we talked about consolidation. Then when consolidation, people got the idea that, okay, I can reduce all these big boxes into one little box and run multiple virtual machines. They kind of started looking at, okay, I can do much more. I can actually virtualize many, many more applications and kind of build in a kind of a virtual infrastructure layer where I can drop in a VM to do an application. Then the whole challenge around doing this was around automation. So then I started doing automating everything they did, like as in the past slide reference, past topic, we talked about Power CLI, right? So Power CLI is a great tool for automation. And not only that, there are various ways of workflow managers like VCO and VCOps. So they all come together very nicely. And you start to build a data center for a particular group or a particular organization. So you start to look at infrastructure as a play where you can think of it as a utility, like a phone bill or a electricity bill, right? So you don't need to worry about the implementation of how do I run the water through the turbine to generate the electricity. So that's what people are envisioning. And now people talk about cloud. Cloud means different things to different people. But let's say that cloud is sort of being the ubiquitous model in the industry today. With all the disruption that is happening, there is also lots of innovation going on from a server perspective. Because of Moore's law, you're increasing the code speed, more memory that is being addressable. There's much more things happening, right? So one of the things we see is storage is also changing drastically. So one of the things that I'm going to focus on is on the flash array. So I'm going to compare the traditional disk-based spindle, which everybody knows. It can do certain revolution per minute. There's a platter. There's a head that reads the data off of it. So we're all familiar with that device. But you contrast and compare it with the flash array. Flash array is made out of memory chips. On a fingertip, you can have 128 gigabytes of data. Maybe that data is outdated as of this minute or this second because they might have been able to cram more gigabytes of space in that space, in that small space, right? So what that gives you is gigantic amount of space, much faster. It consumes less power and is much smaller. So what does this mean to you? For you, when you're looking at a data center deploying different technologies, you have to look at this as a different media as altogether. It is no longer the same, the HDD that you are used to. So that's sort of the background of it. But why is the adoption of this storage not being ubiquitous? If it is so great, if it is so faster, what are all the things that are drawbacks of this technology? Number one is the cost. If it costs me like gazillions of dollars, I'm not going to go buy that. What about reliability? Everybody knows about write where leveling and write amplification and all these different tasks that you need to worry about. How am I going to scale? Is it compatible with my existing application? So these are all some of the factors. Let's take one of the things into consideration. Let's take cost into consideration. That is the number one thing in people's mind because every day you're asked to do more and more with less and less, right? Who haven't heard that mantra before? So what we are trying to achieve here is, you see the flash appliance were used to be very, very expensive, like $20 per gigabyte. Now it's kind of going down to like almost $3 per gigabyte as of today. And it's kind of catching up with the SATA HDDs in a way. So I'm not saying that disks are going to go away. Disks are going to be there. So, but the price point of this with technology like data reduction is even making it much better to kind of go adapt flash technology. So with that as a background, I'm going to dive into multiple ways that flash architectures are available today. Let's take the very early flash adapters. Number one is the PCI base, right? So you heard of a lot of vendors. This is not a vendor pitch, so I'm not going to name any vendors, including my company. So I'm going to be generically talking. You know who they are. So the PCI card vendors, they came into market. When you want to accelerate a application running in a server, you insert that card, you pay X amount of money, and you accelerate that particular application. Declare victory and move on. When the next application comes in, then you do the same. You buy more, and the cards are usually 1 to 3 terabytes. Maybe nowadays we get 5 terabyte cards too, but they're very expensive. You got to be making, take care of that in mind, right? So that is one technology which we are aware of. The second level of technology we've seen is it's in the server side, right? So I'm kind of separating from a server side, the network, and the storage side. The second technology is prevalent is the server attached SSD. So every server today has disk drives in it. So the disk drives can be, SSDs. So these are directly connected to your PCI, not the PCI bus. You go through some kind of a SAS adapter, and you can see those drives. They're like local drives. So instead of being a HDD, they are SSD drives. So that is one approach you can use. So the lack of the software to manage these drives, so you are kind of the mercy of the drives to do garbage collection, doing bit error correction, and all that. So it's like a local direct attached storage story with the SSD. There's nothing wrong with it, just trying to put out there what are the available options. So the drives today come in 1 terabyte, 2 terabyte size. They're going to get bigger, obviously, but I saw some prototypes from Hitachi or some company where they have a 10 terabyte drive in operation. So you're kind of constrained. You got to put multiple of them, and it's going to cost you money to do that. So let's kind of sum up what are all the things that are happening from a software side. I talked about the hardware, the PCI card, and the SSD at the server side. So what else is happening at the server side? The server side, you see multiple of these. I see 3 models. One model is they're using the virtual appliance to kind of create a pool of drives in the local drive and take the SSD and kind of do kind of a tiering model. Or if they're not doing tiering, they're going to take the SSD drive and create a big pool of drives and attach to the VMs. That is one model. The other model is people have written kernel modules for ESX, and you can actually share the drives across multiple nodes in a cluster. Pretty impressive idea. So they're also doing something like taking advantage of the local drives available. As I said, this is not a vendor pitch. There are, VMware themselves have a story where you can combine all the SSD drives and the spindle drives, and you're able to create this gigantic storage where you can deploy virtual machines like that. So there are multiple ways of doing this, right? There are multiple ways to skin the cat, as they say. And also there are other technologies which are using guest filter drivers and using the memory as a way to deploy VMs and do deployment faster and better. Excuse me there. So one of the things that I'm seeing is there are multiple of these solutions, and thank you. And they're easy to deploy. Test and dev is great. And some of them I'm seeing in production also. There's nothing wrong in using all these things. They're not an experimental thing anymore. They're getting into prime time. So I was talking to one of the CEO of one of the companies who does that, and they were saying their business is growing drastically. So things are happening. So that is from the server side. Let's quickly move on. I have 5 more minutes. So let's talk about the flash architectures in the array. So the array, we are already familiar with this, right? So you put a flash cache there in the storage, and you get the benefits of having the flash cache. So this has been time proven. There are well-known vendors who are doing this for a long time. So there is no rocket science here, right? So you put all the hot data here, and when the application comes and hit the data, you retrieve it back. So for all the cold data, you still have to go back to the drives to fetch the data. So that has been proven very well, and it has its place. I'm not arguing one technology is better than the other technology. The other technology is they're actually putting a flash tier into the storage area. So where you can actually have a multiple tiers in there. You could have memory tier, you could have a flash tier, and then you could have a fast SATA and a nearline SATA, and it gets complicated. So you need a rocket science to figure out how do you do all this math to come up with the right formula for the right workload. So again, people are happy with the performance they're getting. People are selling in the market space. There are very successful businesses around it. Nothing wrong in doing it as well. So, but enter the all-flash array, right? So 4 or 5 years ago, companies started toying around, new companies from Silicon Valley, including myself, ourselves, we started toying around with the all-flash storage, and I think this is a compelling thing, right? Spindle media has been in the industry for such a long time, and it has its drawback, and people are kind of working around it by adding these layers of stuff I just mentioned. I think Allflash Array has done a great job in the last 4 years, and it's kind of gained a market share slowly and steadily. And one of the things that is working for them is predictable performance and techniques like data reduction and compression, which your backup admin is already familiar with. You go talk to a backup vendor, and he or she is going to tell you that, hey, I'm getting 10x dedupe on this kind of data. I mean, thanks to Data Domain, they did a great job of kind of selling the deduplication process. So some of the companies are doing dedupe and compression and pattern elimination, lots of clever things. So all that leads to a couple things, right? One of the things is you can reduce the cost of the storage, and you can use actually inferior flash drives like an MLC flash drive. So it's pretty compelling value proposition right there. And also there are a couple ways you can clean up the data. I call it garbage collection. GC stands for garbage collection because it's not a spindle drive, right? So you can't go to a sector and erase the data and rewrite the data. Every time you write data, you actually have to go to a new location and write the data. The old data has to be garbage collected. There are two ways to do it. One way is to do system-wide garbage collection. You have a big software that runs and keeps tracks of where the deleted blocks are and pick them up. Or you let the drives do the garbage collection, so the drives internally knows where the old blocks are, and they delete that. Nothing wrong with both the models, but some models have better things than other models. So that is one thing. So if you're still wondering like why flash array and what does that bring to your into your data center, I would like to present this picture. This is not something I concocted in the lab. This is a published paper out there where what I'm trying to say here is if I access a data via flash, when the data is in the flash, I'm going to get the data. If it is not, I still have to go to the spindle drive to get it. So that's the long tail I/O. If the application sends a massive 64K I/Os, whole bunch of it, I have to see how big my cache is. If I hit the cache, well and good, congratulations. If not, I still have to go back to the drive to get it. So from an application perspective, the application does not complete processing till it gets the hundreds of 64K I/Os. So you're still the long tail in the I/O is still the disk drive access. That's where the all-flash array shines in a way there. It gives you consistent performance for every kind of workload and every kind of workload pattern that's out there in the market space. I think that is sort of my last slide here. I'm kind of running out of time, so I appreciate your time. The key key points I want you to take home is, Flash has been ubiquitous in the data set. You might not even know that you have Flash in the data set. That's my joke there. It comes in various forms and sizes. Some of them I described. The end goal seems to be make your end user happy. How are you going to make your end user happy? You can give them best response time for the application. The person clicks on the Outlook mailbox, the mailbox comes up immediately. Those kind of things matter to people. That gives you productivity increase. So I would encourage you to educate yourself and sort of look at a real application, not look at the hero numbers from benchmark. Take your real application, put it on the array, and try it out. So with that, I appreciate the time. Thank you very much.